Yo, hackers, good evening. This is the first video. I'm actually exposing my voice here in the YouTube space, right? So it might be a bit weird as mostly I focused on posting POCs or kind of small demonstrations. But this is going to be a elaborated video, right? So what this video is all about. So in the last video, I actually solved a challenge, which is actually hosted on the Pico CTA for the Pico gym, where the challenge was actually win anti-debug 0x100, where it was actually a very basic anti-debugging challenge focused, kind of implemented with the IsDebuggerPresent Windows API, right? The challenge was to actually patch the program, and you need to print a flag. It was kind of a very basic program. It was kind of a very basic challenge to be precise. And I actually it was a short video, but I thought, okay, like why can't I start a series on the anti-analysis techniques, right? As it can actually it's kind of one of the kind of an underrated series or kind of an underrated topic, right? Especially on the YouTube on the YouTube space, right? So as I actually mostly deal with the anti-analysis parts and malware stuff, malware analysis, etc. I thought, okay, that I can actually start a series on this. So before starting the actual technical content, I'm going to give you a very basic introduction about the anti-analysis parts and all. Right. So first thing about what is anti-analysis, right? So generally, what happens is like you have a binary or you have a software, right? So if you don't want your software to be reverse engineered by any researcher or any adversary, what you do is actually you actually implement the anti-analysis techniques, right? It can be it can be packing, or it can be packing, or it can be like using obfuscation technique. It depends upon it depends upon the organization, etc. Right? And the same anti-analysis techniques is also being utilized by the adversary, right? Especially by the malware developers and the malware operators. What they do is about they actually implement the anti-analysis techniques within their malware, which actually makes the malware analyst or the threat researcher like forcing them or kind of making the analysis of the binary more difficult, or making the analysis part more difficult, right, of the malware. So generally, what happens is like whenever you receive a sample, right, at some point, what you need to reverse engineer the malware, right? So the anti-analysis techniques actually focused on the reverse engineering part mostly, right? Where what you do once you open the particular like the anti-analysis technique itself is kind of can be categorized into three main techniques. The first one is about the anti-debugging, which we are going to have a look at now. So anti-debugging is something like it's like before getting into anti-debugging, first let me give an introduction about what's debugging. Debugging is something like where it's generally used for error checking mechanisms, right? Generally, what happens, you write a software or write a binary to understand how the entire program works. You can use a debugger where you can actually set breakpoints, and you can understand how each and every line works within a program, right? It's been generally used by both the developers and the researchers too, right? So some of the very common example of debuggers. So general debugging is done with the help of debuggers, and you can actually use like the debugger is actually focused on operating system too. Like in Windows, we have different types of debuggers. For Windows executables or for Linux, we have different types of debuggers, right? The very basic example of how a debugger will look like is this, right? Where of course, I opened the particular binary which we're going to solve, which we're going to patch in this video. This is what the debugging part is about. And what we can actually do with the debugger, of course, that's what I said. Like you can set up breakpoints, you can execute, you can look at the stack contents here, you can look at the register. This is not actually possible with the help of a disassembler. I will give you an introduction about what is disassembler and decompiler, etc. Soon, right? Um, right. So this is what the part of debugging. And generally, what happens, once you reverse engineer malware, you won't be able to uncover the entire technique, right? Because even it can actually leave the researcher, right, by showcasing something else in the expected one to understand to completely understand the binary of the malware. The researcher actually needs to debug to understand how like what are the arguments being passed to the API calls, etc. And like is there any suspicious thing being happening on, etc. That can only be uncovered by the debugging part of the code, right? So the second main category is the anti-VM or the anti-virtual machine technique, where generally what happens in today's environment or in today's information security era, most of the malicious binaries will be executed, within an isolated environment, something called a sandbox, which is none other than a virtual machine, right? So what happens is, um, so the malware authors, what they do, they actually implement techniques even to check that whether their particular malware is being debugged, like, or it's like it is being ran within a virtual machine, right? So there are many techniques focused on that. We will talk about that in any other later video, right? And the the next thing is about the anti-disassembly technique, where you will actually kind of obfuscate the code, or you can use techniques like a metamorphism, right, or polymorphism, like etc., like concepts, like focusing on making the disassembly part more complex. So I can give you an example of how a binary will look at the lower level, right? So as you can see, generally what happens, you write the code, in a C or C++ language, etc., and it actually boils down to at the machine level code, right? So this is what an example of how a machine level code will look like, right? You can This is actually somewhat called as the assembly language. So as a threat researcher or as a malware analyst, you of course need to learn assembly, or even as a reverse engineer as an expert developer, right? So this is what the main part is, etc. Like the debugger or the disassembler, what they do, they actually showcase you that how each and everything works in kind of a graph-based manner, right? The modern day disassemblers, they also have the capabilities of having inbuilt debuggers within itself. It can be take an example of the same cutter where you have the option of doing debugging, the same with IDEA or the binary ninja, etc. Right? As we have different kind of disassemblers and debuggers for Windows. The same is with the concept of Linux, where we have GDB and we have the Red Hat, etc. Right. So what they attack in case of anti-disassembly, what they do is about they can utilize various techniques. Like they can actually obfuscate the entire instructions, like the assembly instructions, which actually makes which actually makes the reverse engineering part more complex, right? And of course, the last is about decompilers, where you can take an example, Ghidra as an example, that's been actually developed by the NSA, the National Security Agency, United States of America, right? Where you can actually decompile the entire code. Where we will talk about decompiler in a different video, as it is a huge topic within itself, right? So now coming to the main core, kind of a core concept or the core technical part of today's video is about the anti-debugging part, where of course, we are going to have a look at the IsDebuggerPresent Windows API, right? So what this particular Windows API does is about it checks that whether the particular process or the process is being debugged by any debugger, right? So how it does, right? It actually does with the help of the being debugged flag, the being debugged the header in within the PEB, the process environment block. So generally, what happens? You know that I guess yeah. Generally, what happens in Windows, if you double click on a program on any executable, it will run as a process, right? And that process has a lot of metadata, kind of being or kind of the metadata part, like kind of embedded within the process, to be precise, right? So what happens is you have a lot of like you have the PEB structure for each and every process running within a system, within a process, right? So some of the very important part within the PEB data structure is the being debugged, the image based address, etc. See, this is not the complete this is not the complete PEB structure, but for the sake of explanation, I just use this particular image, right? So as what I say that the each debugger present, it actually checks the being debugged header, right? The being debugged flag, to be precise, where it is actually a Boolean based one. It actually gives you either zero or one, like true or false. If the particular process is being debugged, then it will actually give you the output as one, and if it is not debugged, then this particular being debugged flag will be zero, right? So how we can check that? Like generally in Windows, as it in operating system or in memory, RAM, etc. Whatever, you can take an example. Registers are the key part, right? We'll talk about the reverse engineering part later on, but as of now, the being debugged, the flags like the zeros or one, the Boolean values are being stored in the RAX or in the EX register, right? So if you inspect if you inspect the EX or the RX register, you will be able to uncover that whether it is being debugged or not. We are going to, of course, have a look at the live demonstration over here. So before that, I have a small code. So what this code does is actually calling the IsDebugger present, right? So IsDebugger present is actually from the kernel30.dll, which is actually something called as the mother of all Windows DLL, right? What it does is actually check. It actually checks that whether this particular process is being debugged or not. So if it is, if checks like it, as what I said, it will check the being debugged flag, and if it is, if it is one, then it will print like what bro is very wrong bro debugger detected, right? In within the message box. If it is not, or if the value is zero, then it will print like no debugger detected, right? So I can give you a live, a small demonstration here. I have my command prompt here, and this is the binary name, the is debug.exe. If I run this, this is a normal command prompt, right? There is no debugger like kind of attached with this. It will say no debugger detected, right? What happens if I run the same program within an debugger? So if I just run this program, it will say what bro, it's very wrong bro, debugger detected. So as what I explained, at the time of explanation, right? This is how it actually works. Now our main task is to pass the binary, and we need to, we of course we are going to debug the binary, but at the same time we are going to modify the flow about printing the printing with this part, like printing that there is no debugger detector. Okay, so let me refresh the window here. So the part is like pretty simple. First, you need to go to the symbols part where you have all the DLLs that are associated with the binary. And as what I say, that is debugger present is actually part of the kernel of the DLL. So if I click on this, if we go down, or I can actually, yeah, I guess I already set a breakpoint here. So as you can see, we have the is debugger present. Let me put a breakpoint here, right? And now let me run the program. And as you can see that it actually stopped the execution, or it actually halted the execution over this particular point where we actually set up a breakpoint, right? So this is where actually the operation is going to perform. So what you're going to do is we are going to step over this function, okay, and it is what the main part here, right? So it is actually, as what I said, it actually tests either the EX or the RX register here. And based upon the operation, it will jump to this particular program. It will actually jump to this particular part of the program where it will preserve, where it actually print the result that whether it is being debugged or not, like the final message, the message box, right? So as what I explained here, that you need to check the EAX register here. I guess it is visible. It is currently one, which is meaning that it is actually being debugged. So what we will do, we will just like our main goal is actually pass this particular binary. So we are going to pass the EX value, right? So I'm going to modify value. I'm going to make it zero, okay? Or else this is one part of scenario where I utilized the same technique in my previous video. So we are not going to focus on that as of now. Uh, just for sake of explanation, I did this, okay? So what we are going to do, instead of jumping, as we know that this is one, it's not going to take a jump to this particular part. Of course, it's going to not this particular part. Of course, it's going to take a jump to this particular part of the program. So what we will do, we'll pass the binary in such a way that it will always print this particular part. That means like no debugger detected, right? So to do this, we'll actually change this from jump equal uh, to jump part, right? Instead of jump equal to, we will change the particular instruction to jump. So okay, here we have the assemble where we have the jump of zero, and of course it is not zero, so we'll directly go into jump. Okay, and let me cancel this. Okay, so as you can see, now we actually changed to be precise, we actually passed the binary. So to save this particular binary, what we can do is about we can click on the patches part, and it actually shows us all the patches or all the changes that we made to the binary. So I want to click patch file here, and I want to say like is debug patch.exe, right? And it says okay. So now what I'm gonna do is I'm gonna open the same. I'm gonna open the past binary here. It might ask us for limited privileges. Yeah. Okay. So now if I run the same program within the debugger, you can see that no debugger detected. This is what the usual flow of how patching works. This is a very basic example of how patching works, right? As soon as we dig deeper into the anti-analysis part, we will, of course, we will walk through many complex situations, and we also try. I will also try to bring out some real life examples focused on malwares, right? Of course, the debugging technique or the anti-analysis technique has been also used by the malware. So, of course, I will make a video about the techniques that's been, the same techniques that's been used by other malwares too, and we'll also try to patch them. Okay. So yeah, that's for all about this video. And before the end of the video, I just want to give you a short, quick kind of an alert over the next series that I'm planning to launch a new series. So I focus on the APT, which is called as the Advanced Persistent Threat, and the APT attack simulation. Uh, which of course I will be. I'm currently working on that, and will definitely post that soon, right? And of course, we are going to also start a series on binary exploitation, by the way, focusing on both Linux-based binaries and also Windows-based binaries, right? So we actually kind of in a track of covering three main things or three main series parallelly. The one is about the anti-analysis part. The second one is about the kind of uh, the binary exploitation part, and the third one is about the APT and the insights and the APT attack simulation part. Okay, so thanks for your time, buddies, Yokas, yeah, hackers.